Yeah, I'll accept Bitcoin, you know. A couple of shares, you know, or a couple of Bitcoins, you know, that'd be real good.
Yeah, my Dogecoin goes up.
Dogecoin is going up.
Okay, so I believe we already did this one, right?
Yes.
Zinc.
Yeah.
I have to remember which class is which. This is
the
this is a really good class that's always a little bit ahead of the other one, right?
Yeah.
And don't tell the other class I said that.
Okay.
Okay, so now we get to talk about activity series. Can you guys see my screen? Usually I'm talking and nobody knows what I'm talking about.
Yeah.
Okay, so the way activity series works is there's a hierarchy, right? So you know how we were doing that single replacement reaction earlier with the zinc and the copper?
Yeah.
Right? So we had zinc reacting with copper nitrate, copper 2 nitrate. And we got zinc 2 nitrate. And copper solid. Now, the activity series has a hierarchy associated with it. If you look where zinc is at, and you look where copper is at. So since zinc is higher than copper, zinc can replace copper in a compound. Okay. Now, if we had platinum reacting with copper, there wouldn't be a reaction. In our sense, for no reaction. Okay. So because copper is higher than the platinum, so the platinum can't replace the copper. Okay. You guys see that? You understand that?
Yes.
Okay. So now I'm going to see how much you guys understand here. So there's a little bit more to it here as well, because hydrogen is also in that group 1 area. So hydrogen can be replaced, let's say hydrogen from water, steam, or an acid can be replaced by lithium or any of the guys up here. Okay. Hydrogen can be replaced by steam or an acid by the guys here. Hydrogen can be replaced by an acid by these guys, and these guys down here, because hydrogen is above all of these guys, they can't replace hydrogen.
Right.
So let me give you an example.
Oh, so why is hydrogen in its own category? I just noticed that.
If you look where hydrogen's at, it's right above the metals on the periodic table.
Okay.
Because at points it kind of acts like it's a metal, even though it's not.
Okay.
Okay. So if we had hydrogen gas with copper, in this case, we're going to get nitric acid and copper solid. So let's balance this out. Okay. because hydrogen is above copper. Now, if we had it the other way around, where we had nitric acid, and copper, this guy would be no reaction. Okay, because copper is below them. Okay, you guys understand that? Do you see it? Yes, no, maybe?
Yeah.
Yes.
Okay, so now I'm going to test it out. Okay, so if I have lithium here, what's going to happen?
Would it replace the copper?
It's going to replace the copper. So then we're going to get lithium nitrate. Okay. So what if I have silver and copper 2 nitrate?
No reaction?
That's right, no reaction. Okay, pretty good. You guys are looking kind of fancy there. Let's see if we can do you something a little more challenging. So we have oops, CO. Okay, so let's see. We'll start off with, let's do manganese. Okay, so in the first case, what's going to happen?
The manganese is gonna replace the copper.
Okay, so we're going to have come on, you guys know chemical formulas? Let's go. What would be the chemical formula of what we're going to get? Oh, I did forget one thing. I think I told you last week. I mean, not last week, on Monday. If you have transitional metals, they're always going to end up being +2, except for silver and aluminum. Okay, so if you have transitional metals that are replacing other metals, they're going to be a +2 charge associated with it. So what are you going to get on the other side for your products?
Mn +2.
Am I just going to write Mn +2?
No.
So we're going to write our conventional equation, not our ionic equation. So what are we going to get?
Would it be just Mn and then NO3? And then
Okay.
the charge of NO3 is -1, so you need 2
Okay,
parentheses, and then 2 outside, and then plus, that's in AQ,
okay.
and then plus CU.
And what's the state of CU? Is it gonna be solid, liquid, gas, or solid, liquid, gas?
Solid.
It's kind of like, is it solid, or solid? Okay,
It's
what about
solid.
What about the second one?
Uh,
It will replace it.
Okay, so what are we gonna get? And are you confident, 100% sure?
Probably
Well,
is no reaction.
Is it?
No reaction.
You said no reaction? Okay, so one of you say is no reaction, and one of you say that it's gonna replace it. So why would it replace it if it's no reaction? What does it say here?
Will replace from steam or acid.
Okay, so is this a steam? H2OL? Is that
Yeah.
steam?
No.
Is it an acid? Is water an acid?
no, it's liquid.
Okay, so we know it wouldn't replace it in this case. So there wouldn't be a reaction. Okay, what about here? We have
It will.
Mn.
Gas.
Okay, why?
Yes.
Because
Gas.
G means a gas, right?
Yeah.
That means it's steam. Okay, so what are we gonna get? Are you there?
Would it be Mn then O?
Okay,
And then plus H2?
Well, what would be the state of MnO and
Would it
H2?
be solid?
Actually, no,
AQ.
AQ. And this guy is gonna be
Solid.
That's right.
H2 is a solid.
No, it's a gas, right?
It's a
Gas.
gas, that's right. Okay, now what about this last one? Oh, is it balanced? Yeah, I guess it is. Huh?
BM and then Cl2 plus H2.
So Mn, and you said Cl2
Yes.
plus H2.
Yes, that's correct.
And this guy,
Would it be AQ?
okay. Okay, feeling confident? Let's see who's here. There's only 16 of you guys here. What's going on?
That looks pretty good.
Andres, are you feeling confident?
By looking at this, yeah.
Yeah, okay, we're gonna test you out. We're gonna throw a curveball you guys' way now. Okay,
All right.
let's see. We're gonna go Okay, so we have Ba plus Sr or strontium nitrate. It's going to happen.
Gonna replace it, BA.
It's going to replace it. So what are we going to get?
It's going to be BaNO3. It'll be NO3 too.
The parentheses 2.
Yes.
Okay. And
then plus SR.
okay. What about down here?
No reaction.
Are you sure?
No, right? Because liquid will replace H2 from liquid water.
Ah, so it will replace. Okay, so then what would be the chemical equation?
BaO.
Okay,
Aqueous plus H. Two gaseous.
okay. Okay, what about here?
Replaces it as well.
Okay. Same thing.
Yeah. Had to double check that one because I was waiting for you to trick us on it, but I don't see anything.
And what about the last one?
Wouldn't it be BA what CL?
Okay,
Cl2,
Cl2, that's right.
and then plus H2.
Is it balanced?
Don't forget the states.
Yes, ma'am. What would be the state here?
Equal.
Aqueous.
Okay, is it balanced?
No, it's not.
What do I need to do to balance it?
2 in front of
And
HCl.
add it. Yeah.
Okay, piece of cake, you guys got it? Okay, and you have this table in your handouts or in your resource tab.
True. I was wondering where we were going to use this.
Okay,
It's nice when everything starts making sense.
yeah, look at, I mean, think about where you guys were at the very beginning.
Woo!
I have that very first test of some of you guys doing chemical equations. Man, I was almost in tears. I was like, oh my God, Lord Jesus, help me. And then today, look at this. Look what you guys are capable of.
Real chemists. Look at that.
Yeah. You're predicting reactions now. Okay, so you guys are very familiar with combustion reactions, right? So a combustion reaction is just the same thing as an oxidation reaction. So when we're talking about organic chemistry, organic compounds, and they use the term oxidation, really what they mean is that they're adding oxygen to react with that hydrocarbon, okay, or that organic molecule. Okay, so they give you kind of like a generic equation. So we always know that this guy, you're going to end up with carbon dioxide and water. Usually if it's burning, water is going to be a gas, right?
Right.
Gas, 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 right?
It's a gas.
So let's see if you guys remember anything that you guys were taught since the very beginning. Write the write the equation for the complete burning of ethanol. So we always know that anytime that anything is burning, you always have oxygen. Or if they say if it's oxidizing of ethanol, you know that that means burning. Okay. Okay. How are we going to do it? Where are we going to start?
You have to
Okay.
write the reactants first, right?
Okay, so what are my reactants?
Would it be C2H6 and then the oxygens? I don't know.
That's right, C2H6, and you said oxygen, right?
Would it be plus oxygen?
Plus oxygen.
And then yield
Is it just oxygen with an O, or is it
O2.
O2? Is that a
It's an
solid, liquid, or
atomic-
gas?
Would it be
Would it be a gas?
gas?
That'd be a gas.
Gas.
And we're gonna make
Ethane.
ethane.
No, you're
We're-
not making ethane.
We're starting with ethane.
We're starting with ethane.
Okay,
Didn't you say we make carbon dioxide and then
and
is it H2O?
that's right. So all combustion reactions you're gonna get the same thing. All combustion reactions with carbon, or I should say organic molecules, you're always gonna get carbon dioxide and water. Is it gonna be a solid, liquid, or gas?
Liquid.
It's gonna be a solid, liquid, or gas.
Gas. Everything's gas.
Okay, think about it. It's burning.
All liquid.
It's burning. It's steam. It's like
Okay, so is it okay? You need a
okay.
T in your life. Okay, is it balanced?
No.
No.
No. How do we balance it?
You could put a 2 in front of the carbon dioxide, and then you can add a 3 to the H2O on the product side.
You said a 3. Okay. So then that gives me, what is that?
That
2
gives you
carbons.
So
How many
4,
oxygens?
7,
4,
5, 6, 7.
7.
7 oxygens.
Yeah.
And
6.
okay,
Hydrogen. So 6
Hmm.
and 2. And we can add a 7 in front of oxygen too. 7/2.
7/2.
Yes.
Okay, so we know we can't have a half of a molecule.
So
So,
the 2's cancel out. So we multiply by 2,
okay,
the whole equation.
so we get 2,
Would be 2C2H6 plus 7O2. And then would be 4CO2. And then 6H2O.
Hey, Dr. Henry, do you write all these with your mouse?
yeah, with my, not with my mouse, with my keypad.
Oh my
By
god.
the end of the day, my hands are so stiff, yes. I used to do it with my mouse, but my mouse doesn't work on my new table or I have this stainless steel table since I've been doing experiments and stuff, so. Okay, questions, concerns, Cash? Bitcoin? Okay, perfect. We're moving forward. Okay. So when we have a double replacement reaction, we can end up with precipitation. When we end up with precipitation, that basically means that a solid is formed. So how have you guys been figuring out what you're precipitating or what solid is forming? Or have you? Just gonna roll the dice and see what I get. Is that the way you've been doing it?
No.
No? So there is a beautiful table that helps us figure this out, right? I'm going to show you this beautiful table that's going to help you guys figure it out. And then I'm also going to show you the rules, right? And so you could use the tables or you could use the rules, right? Or use a combination of both. Okay, you guys ready to learn?
Ready.
Yeah.
Okay, good.
Born ready.
Okay, so the way this table works is that you put things together. So for instance, we have aluminum acetate. So aluminum acetate is slightly soluble. Anything that is in orange or in, if it's, I can't tell if you guys, if it's pink on your screen or if it's orange on your screen. It's orange on my screen.
It's salmon.
Okay, I'm sorry, salmon.
Just kidding.
If it's salmon on your screen, then that means it's gonna form a precipitant, okay? So slightly soluble basically means that most of it precipitates, but you have just a little bit that's able to go in solution. Nearly insoluble basically means the same thing as slightly soluble, right? You got a lot of precipitate and you have a little bit that goes in solution, okay? You guys understand? See how it works?
Yeah.
Okay. So I'm gonna write a couple things up here and I want you to tell me whether or not it is if it's aqueous or if it's a solid, okay? So the green means it's soluble, means that it goes into solution, okay? Let's see.
So we're telling you whether it's soluble or not soluble.
You're telling me if I'm gonna put an S by it or if I'm gonna put an AQ by it.
AQ by aluminum brome.
Let me put them all up there first and then I'll give everybody a chance to think about them.
Okay, sounds good.
Is that fair? Okay. So let's start over here with the aluminum bromide. Is that gonna be aqueous or is it gonna be a solid? Okay, what about cobalt phosphate? Cobalt 2 phosphate.
Solid.
How about copper sulfate, copper 2 sulfate, sorry.
Aqueous?
What about copper 2 sulfite?
Solid.
Actually, I gave you one. That actually, I think it decomposes, so it won't exist. That's a bad one. Give you, oh yeah, copper. I should have went cobalt. What about cobalt sulfate?
What do we put if it says decomposes?
Then there's no reaction in that case.
NR.
Yeah.
Oh, okay.
No blackout bingo.
Okay, what about ammonium phosphate?
Would it be solid?
Ammonium phosphate?
Aqueous.
Ammonium phosphate. It's going to be aqueous. What about iron 3 chloride?
Aqueous.
Aqueous.
And what about iron 2 oxide?
Aqueous.
Are you sure? Iron 2 oxide. I'm
Where
sorry,
is that
iron
on
2,
there?
sorry, iron 2 hydroxide. I bet.
Okay.
Oh, would it be solid?
Okay, you guys get it?
Yeah.
Round 2.
Okay, let's see if we can make it a little more complicated. Okay, let's say, I'm gonna add the other sheet here. Okay, so here's more of the table. So it's 2 tables actually. Let's say we have, we'll go NH4. Okay, I got it. NH4. CO3. So what would be the chemical reaction for this guy? Or would there be a chemical reaction?
Aqueous. Never mind. I didn't see the second part.
Can you guys see it?
Yeah, now I can. I'm on my phone, that's why.
Okay. Okay, so we have these 2 reactions, 2 chemicals reacting. Are they going to react, or is there not going to be a reaction? Or are there going to be, what's going to happen? Tell me what's going to happen. What am I going to get?
Wait, are we trying to find the products of those two?
Yes, ma'am. Yes, you're trying to find the products of the 2 reactants. What's going to happen?
NH4 with NO3. And then 2.
It's going to be solid, liquid, gas, or aqueous.
Mm. Would it be solid?
Okay, do me a favor. We have ammonium nitrate.
Aqueous.
Find ammonium nitrate. Ammonium, and we go over to nitrate.
Right there.
So it says soluble. Soluble means that it dissolves. So if it's green, it dissolves. So that means it's going to be aqueous. Okay, and what else are we going to have?
AgCO3, but in parentheses.
AgCO3.
Yeah.
Okay, silver. Silver, what is the charge on silver?
Is it
2 plus
Nope,
1.
1. Silver is 1. Okay, so how many silvers am I going to need to balance out carbonate?
Just one, right?
2.
2,
Or
you
3?
because carbonate has a negative charge of 2.
It has a negative charge of 2, so how many will I need?
Oh, two.
2. Okay, so it's
Solid.
Ag2, CO3, and it's going to be a solid.
Mm-hmm.
That's right.
Is it balanced?
No.
Okay, so what do I need to do to balance it?
would you put a 2 in front of the AgNO3 on the reactant side?
Okay. Oops, I screwed up.
Mm-mm-mm.
I know, my brain isn't working today.
Unacceptable.
Oh, but at least I caught it before I hit submit. Okay. Does that help a little bit?
Yes.
Okay. So is that balanced now? Yes, no, maybe.
Maybe.
Maybe? Okay. Okay. But you see how to use the tables?
Yeah.
Okay. Okay, good.
Is this reaction double replacement?
Yes.
Okay.
Yes, it is. Okay, so let's talk about solubility. The way that you determine solubility is you remember these rules. So all alkali metals, all the metals in group 1, they are always going to be soluble, right? So they're always going to be able to be dissolved in water. Ammonium is always going to be soluble, okay? Nitrates are always going to be soluble. Nitrite is almost always soluble except with silver. It's not soluble with silver. Chlorate is always soluble. Perchlorate is always soluble. Acetates are almost always soluble except for aluminum and silver. The halides, so your halide ions, so that's chlorine, fluorine, iodine. are almost always soluble except for when they're with silver, mercury 1 ion, and the lead 2 ion. Fluoride is almost always soluble except for group 2 metals and lead 2 and aluminum, the aluminum 3+ ion. Sulfates are almost always soluble except for group 2 metals and lead 2+. Now, these guys are almost always insoluble. So carbonate, phosphates, oxalate, chromate, except for when they're with group 1 metals and ammonium. Your sulfides are almost always insoluble except for group 1 metals and ammonium. And then your hydroxides and your oxides are always insoluble except when they're with group 1 metals, ammonium, and barium hydroxide. Barium is with hydroxide. Okay, so which one is easier, this or the table?
Table has more information.
Okay. They say the same thing essentially.
They do, I guess, but I don't know. I guess I like both.
Okay, so let's test it out. A solution of lead 2 nitrate and sodium bromide are combined. Write the net ionic equation for any precipitation reaction that may occur. So we want the net ionic equation. So we're going to start off first with the conventional equation. So what would be the conventional equation?
Reactant and product.
Okay, so I'm waiting for you to tell me what is our reactants, and then tell me my products.
PB.
Come on, let's go.
Sorry, I was talking and I was muted.
NO3 in parentheses and then 2.
NO3 in parentheses and 2. Okay.
Plus NABR.
Okay, what are the states? Solutions of lead 2 nitrate and sodium bromide.
Aqueous.
Aqueous.
Didn't you say the nitrates are they're soluble, huh?
Yeah. So they're both aqueous. Okay, what are we going to make?
Is it PBBR plus NO3 2 Na?
You mean Na, NO3?
Yeah.
Okay. Now don't forget the rules now. So is that right? Are you missing anything?
Yeah, the states.
And also for PP.
The NO3 has a 2 on it. Or the NO3 has a 2 on it, so there would be 2 of the NO3s.
Isn't it PBBR2? Because
Okay,
lead has a charge of 2+.
That's right. So it should be PBBR2. And what would be the states? And then we'll talk about the balancing, right? Because what you put in, you must get out. What are the states?
Would it be AQ?
Let's go back and look, right? So you guys don't have your
So-
tables.
Yeah, lead,
So we have lead 2.
lead 2, and what's the other one? Oh, let me see. Br2. It's slightly soluble, so
Would it be liquid?
slightly soluble, so it's solid.
Solid.
And then you got NaNO2, Na sodium, sodium. Well, actually, hold on a minute.
AQ.
AQ, that's right.
Good job.
Okay. You guys see the sodium
Yeah.
nitrate?
hmm
Okay. So remember, pink, if it's pink or salmon, then it's going to be a solid.
Solid.
If it's green, it's going to be aqueous.
Aqueous.
Green or mint.
Sorry, green or mint, aqueous. Okay, now, is it balanced?
It's not.
We got to balance
Not.
it.
Okay, so that means we got to balance it. Okay, so what do we need to do to balance it?
2 in front of NaNO3
BR
and NaBr.
on the reactant side.
Okay, so then that's balanced, right?
Mm-hmm.
Okay, so Michelle, now you see why, even though you have 2 nitrates, we accounted for them by having the 2 over here.
Yeah, I see.
Yeah, so you always want to remember, first you have to get the chemical formula right. Chemical formula is always based upon the charges of the 2 guys that are interacting with each other. So we want to make sure those charges equal 0. Okay, so what is the next step? So now we have the
Conventional equation. So we need the net ionic equation.
Okay, so we need the total. Let's get to the total first. Then it makes it easier to get to the net. So what would be the total ionic equation?
Would it be PB plus?
PB plus? What is the charge on PB?
2 plus.
2 plus. Okay.
Then
And is
plus,
that going to be solid, liquid, gas, or aqueous? So what's going to be the state? Solid, liquid, gas, or aqueous?
Accurate.
Okay. AQ plus
would it be 2NO3? And then
Charge?
there's a negative charge of 1.
Okay. Solid, liquid, gas, or aqueous?
Aqueous?
Plus
2Na.
is there a charge?
Yes.
Plus.
Solid, liquid, gas, or aqueous?
Aqueous?
Okay. Plus, what else?
BR.
BR2.
Charge. Negative charge.
Okay, Br. So 2Br, negative charged, AQ. Okay, what about your reactants? Slide this over real quick.
Should be PB2 plus.
Would it be PB2 plus? What is that rule about solid, liquids, and gases? Girl, just leave me alone. Leave me alone. Oh, oh.
So they're solid.
So it's a solid. So we're going to leave it alone, right? So if
Mhm.
it's a solid, if it's a liquid, if it's a gas, we leave it alone. The only time that we break it up is if it's aqueous.
Okay. So would it be PBBR too?
That's right.
Be a solid,
I'm gonna break this up now.
and then 2 plus 2 Na, and then a plus charge,
Okay.
plus 2 NaO3.
Okay, so now who are the spectators?
Ooh, this is good. Okay, let's see.
PBBR2.
2NO3 negative aqueous.
Okay, what is the rule about spectators? Remember, they just come to the party to watch. So you see them on both sides.
Yeah.
Exactly the
2NO3.
same. You said 2. What was
Na
it?
plus,
2NO3.
2NO3. And
And
Na
the
plus,
Na.
Na, 2Na plus.
Mm-hmm.
Okay, so who are we left with?
2B2 plus aqueous.
You mean PB 2 plus?
Oh yeah. Dang, I'm dyslexic tonight.
still,
And
2BR
oh yeah, 2BR.
minus aqueous.
okay,
Yield PBBR right back to solid.
okay, piece of cake. So this is our total, our net ionic equation.
That's a lot of work. How many points is that going to be on the exam?
You guys are only going to get 10 questions.
I was about to say, it better not be no 1 point problem. Wait, what's going to be 10 problems or questions? The fourth exam?
Yeah,
Are you serious?
yeah. Just
What was
10
that?
questions.
Oh, 10. Isn't it the total ion equation the last one?
Nope, the total ionic equation is the total ionic equation. The net ionic equation is just what's net. Net takes out the
Okay.
spectators.
All right, ready for the next step.
Okay, you guys ready for the next step? Sorry. My family forgets that I work, and so they always want to try to call me when I'm in class. Okay, let's see. Let's clear this out. Okay, so neutralization reactions go through the same process because the neutralization reaction is exactly like a double replacement reaction. It's just a special form of it. Okay, neutralization reaction is it's when you have an acid and a base, and then you end up with water and the salt. Okay, so do you guys want to give it a shot?
Of course.
Okay. It says write the conventional ionic and net ionic equation for reactions of solutions of hydrochloric acid and sodium hydroxide. So where are we going to start?
With HCl.
Solid, liquid, gas, or aqueous?
Aqueous.
Okay. And
Then would it be Na?
NaOH.
okay. Solid, liquid, gas, or aqueous?
Aqueous.
Okay, what are we going to make? What are we going to get? Since it's a double replacement reaction?
Would it be NaCl, Cl, and then H2O?
Yeah.
Okay, for the NaCl, are we done? Is there anything else we need?
The state.
Okay, what is the state?
Aqueous.
Okay.
Liquid.
Okay, so that would be our conventional equation. So what about our net ionic equation?
Would it be
I'm sorry, our total ionic.
H plus Cl negative charge?
Oh, by the way, was it balanced? With conventional?
Yes,
Okay, good.
I checked it out.
Okay.
And then plus Na plus. Plus O minus.
Is it O minus?
Oh, it's
Oh.
OH.
Okay. Are you forgetting anything?
Yes, the state.
Okay. So all aqueous, right?
Yes.
Okay.
Na plus. And then plus Cl negative charge. Then plus H2O. Liquid. Then AQ for Na and Cl.
Okay, who are the spectators?
Get rid of Na and Cl.
Okay.
Send the bouncer in. Bounce them out of the party. No one likes a peeping Tom.
H plus aqueous plus OH minus negative charge. and then yield H2O liquid.
Piece of cake?
Yes, piece of cake.
That was so fun.
Excellent. You guys ready for another?
Yes.
Yeah.
Ready?
Okay. Oh. Okay, so let me give you a little more information first. Let me clear this. Okay, so these three ion combinations, so basically when you get the hydrogen ion with the carbonate ion, it forms carbonic acid. Now, as soon as it forms carbonic acid, it actually will change into carbon dioxide and to water. So the carbonic acid is an intermediate. We call that an intermediate because it doesn't sit around long enough for anything to happen. Okay, so that's the same thing that happens with hydrogen and sulfite. When it comes together, it forms sulfurous acid, and then it immediately changes to sulfur dioxide and water, and this should be a gas, not when we have ammonium and hydroxide, then it forms ammonium hydroxide, and it only does that temporarily, then it forms ammonium and water. Ammonia and water. Okay, you guys got that? Yes, no, maybe?
Maybe.
Okay, let's see. Okay, write the conventional, the total ionic, and the net ionic equations for the reaction between solutions of sodium carbonate and hydrochloric acid. So where are we going to start?
With the HCl.
Okay.
Plus
Is it
NaCl.
S?
Someone's actually paying attention to class. They forgot about the food.
CO3.
CO3.
Na2CO3. Okay. Are we forgetting anything?
Minus on
They're both aqueous.
the CO3 is a negative. Oh.
Okay, so what are we going to make?
NaCl.
Excuse me.
Bless you.
Thank you.
NaCl, and then a
No.
What is the state?
Ooh, aqueous.
Aqueous, that's right. And remember, double replacement reaction.
would it be CO2?
Okay. And solid, liquid, or gas?
Be gas.
Okay. And
O.
Are you sure it's HO?
OH.
What was that?
OH.
OH?
H2O.
H2O. Okay. Okay. Okay, is it balanced?
No.
Okay. What do I need to do to balance it out?
Can add a 2 in front of HCl in the reactant side.
Okay.
And then a 2 in front of NaCl on the product side. So that balances
Okay.
the sodium.
So now it's balanced?
It is.
Okay. Okay, so that would be our conventional. So now what about our total ionic?
BH plus on 2H plus
2H plus.
and then
AQ.
AQ
Okay.
and then
Is it 2Cl minus AQ?
Okay.
Plus,
Na2.
You mean 2Na?
Na, yes.
then plus CO3. Would it be 2 minus
Okay.
and then AQ plus 2Na. Oh no, it would be yield and then 2Na plus AQ plus 2Cl, negative charge of 1 AQ.
Okay.
And plus CO2 and then gas and then plus H2O liquid.
Okay. Okay. So who are the spectators?
2Cl
2Na.
minus AQ.
2Na plus aqueous.
Okay. Okay, so then what would be the net ionic equation?
Would be 2H plus AQ
Plus CO3 to negative AQ.
yield CO2 gas. CO2
Plus
and then
H2O
gas.
liquid.
Okay. Piece of
Ta-da.
cake. Okay. Let's see how much time we have here.
30 minutes. 38 minutes.
We have 38 minutes.
wait, what?
Does class end at 7:30 or 7?
7.
7.
Oh, trying to get some more
Okay.
time in here.
So, so this is just like similar. We can do the same equation and everything like that when you have something that's a solid and a liquid, and then you can end up figuring out what's going to be produced, right? So I'm going to let you guys do this one on your own. May end up seeing it on a test or something like that.
Hint, hint.
Come on. Okay. Let's see. Yeah, this is the one I wanted. Last thing I want to talk about. Okay, so occasionally we'll end up with an equation that doesn't give us anything, right? So if we take a look at this equation, we have sodium chloride and potassium nitrate. So what are the chemical formulas for sodium chloride and potassium nitrate?
NaCl.
NaCl.
Then K. NO3.
Okay, so then they're both aqueous because they're solutions, right?
Yeah.
And since this is a double replacement reaction, we'll know exactly what we're going to be making on the other side, right?
Yeah.
So we get sodium nitrate and potassium chloride. So if you use your table, is that going to be solid, liquid, gas, or aqueous for the sodium nitrate?
Wouldn't they all be aqueous?
That's right. They're all going to be aqueous. That's right. So they're all aqueous. So then basically, anytime that you see that everything is going to be aqueous, this is not going to be a reaction. So this is going to be a NR. No reaction. Okay, because everything is going to be in an ionic form, they're not going to interact. You're not going to get a precipitant. Okay, piece of cake.
Piece of pie.
So the net ionic equation would be NR. There's no net ionic equation. Or no equation. Any. Okay, so this just sums up everything that I taught you in a nutshell. Are there questions?
When you have that NR reaction, does that happen when in other forms like
Yes. Yeah.
gas and solid? Probably not solids, but
yeah. So sometimes we have two gases that are inert. Like if you put hydrogen and oxygen in there and you don't stick any electricity or enough energy, it's going to give you an NR2. You're going to end up with just the hydrogen gas and the oxygen gas. That's kind of like the air, right? Because we've got a lot of hydrogen in the air. They don't interact with each other. It's only when we put some energy into it that we can get them to interact. So yes, it does happen quite a bit. Or if you throw penny into water, you know, penny is copper, right? Does anything happen?
No.
Your penny? Nothing. Right? That's how we can throw money into water fountains, right? Or in wishing fountains. Or
you get your wish. That's what happens.